This one is the sucker rule. This has lots of applications in math. We talked about it last week when we were talking about subtracting negatives. This also works for fractions. You can also find it in algebra. Basically, the concept is that if you had two kids sitting next to each other, you gave one of them a sucker, you have to give the other one a sucker, they're going to cry. So everything has to be fair, and that is true for math. When we're adding fractions, we already know this, you have to have same denominators, right? If you have different denominators, you got to fix that. So we already talked about how to find a common denominator. In this one, it's going to be 20. That's a pretty easy one. Once you have your common denominator, this is where people get a little confused. Sometimes they just leave that 20 there and they add straight across on the top. The problem is that we've changed this fraction. This used to be in fifths and now it's in 20ths. So we've got to fix that. We've got to change the top two. So the way I like to do this is I look and I say, how did I get from 5 to 20? Well, I multiplied by 4. Well, I gave this kid a sucker, so now I have to give this kid a sucker. 5 times 4 is 20. 3 times 4 is 12. Okay, I do the same thing here. How did I get from 4 to 20? Multiplied by 5. Gave the 4 a sucker. Got to give the 3 a sucker now. 3 times 5 is 15. Now I have my 20, which is the denominator, or like I like to call it, the dominator, because it's dominant. And then I add 12 plus 15, which is going to be 27. That's the same as 1 and 7/20. I'm going to take a sec and show you one on the whiteboard too, because I think this one's a little bit trickier. So here we have, sorry, sometimes it comes out wonky when I write on the whiteboard. 11/18 minus 5/12. This one's not as easy to see what the common denominator is, which is why I wanted to show you this. So this is what my problem is going to look like when I'm done. That's supposed to be equals, but I'm going to use my factor tree like I did in the other problem to find my common denominator. 18 is 3 times 6. 3 is prime. 6 is 2 times 3. Okay, I'm going to write that down here. 18 is 2 times 3 times 3. Then I go to my 12, which is 3 times 4. Sorry, that 4 went wonky too. Looks like a 9. We'll change it like that. 3 times 4. 4 is 2 times 2. Those are both prime. So I write 12 here, which is 2 times 2 times 3. So really similar numbers. I'm going to take one of these. I just take the first one and write it down. 2 times 3 times 3. Remember, I want everyone accounted for here. There's a 2 and a 3 and a 3. Those are all good. Go to my 12, I need 2 2's and a 3. Well, I have 1 2 and I have a 3, but I'm missing a 2, so I'm going to put another 2 in here. So 2 times 2 times 3. I could really write it anywhere. I just stuck it there because I like to keep it tidy. So 2 times 2 times 3 times 3. I multiply those together. This is basically 4 times 9, which is 36. So my common denominator for 18 and 12 is going to be 36. Some of you who are good at doing math in your head could have figured that out yourselves. I'm not good at doing math in my head, so that wouldn't have been as clear to me. So 36 is your common denominator. Now I'm going to use my sucker rule. How did I get from 18 to 36? I multiplied by 2. If you're not sure, you can use a calculator and say 36 divided by 18 and it'll tell you 2. So you say 18 times 2, give this kid a sucker, gotta give this kid a sucker. 11 times 2 is 22. I do the same thing here. How did I get from 12 to 36? I multiplied by 3. Give this kid a sucker, give this kid a sucker, and I get 5 times 3 is 15. Now I have 22 minus 15 on the top, and that gives me 7, and I get 7 over 36, which cannot be simplified.